All right. Anybody have a homework? Question. Let's start with that. Any homework? Questions? Posted all the answers. Oops. Tommy?
Number 6 on 9-3.
9-3. Number 6 says, if two cars are selected at random, what is the probability that both are big bombs? How many cars are there altogether?
25.
So the denominator is going to be 25C2 because there are that many ways to pick 25 cars, or to pick 2 cars out of 25, right? That'll be the denominator. Now, what do we want to have happen? We want the ones we pick to be big bombs. Well, how many of those are there? Yep, so there it is. That's the answer to the question. That problem is no different than a card problem. If I said, what's the probability of being dealt a 5-card hand, all diamonds? Wouldn't you say 13C5 on the top and 52C5 on the bottom? Yep, same exact concept. Same exact thing. Don't overcomplicate it. Same thing. And you can type that straight into your calculator. Anybody else have something on homework to look at? Natalie?
Can you do 9.2, number 8?
9.2, number 8. All right, so with n factorial over n minus 2 factorial, n minus 2 factorial. We're going to add to that n plus 1 factorial over n minus 1 factorial and n plus 1 minus n minus 1 factorial. And hopefully all that's going to reduce and just give me n squared. So I use my formula, which you're supposed to have, So here we go. Let's clean up these ones that have subtractions in them. So this will be n minus n plus 2. So that's just 2 factorial. Because the n's cancel. And this one, this is going to be n plus 1 minus n plus 1. So that one's just going to be another 2 factorial. Okay, now, what's n factorial? N minus 1, n minus 2, da-da-da. So this is going to get to the point where it's going to cancel with that. So all I'm going to have left on the top is n and n minus 1. And then everything else is going to cancel with that. And I've got my 2 factorial still down there. And the same thing's going to happen here. Because you're going to have n plus 1 and n. But then after that, it's going to cancel with that. So we've got n squared minus n plus n squared plus n all over 2 factorial, which is just 2. And the n's cancel, so we're left with 2n squared over 2, which is indeed n squared, what we wanted to add left. All right, anything else from homework? Philip?
9-1-10.
9-1, number 10. Any customer institutional equipment? How many different cars can the customer order? Well, this is going to be big because we could get how many different, any combination of up to 6. So we could get none, 1, 2, 3, 4, 5, or 6 accessories, right? So I know I'm going to pick a car, and I'm going gonna pick an outside color and an inside color. So I know right off the bat, there's 3 times 4 times 5, right? 3 cars, 4 exteriors, 5 interiors. So if I don't pick any exterior, or I mean any accessories at all, then that would be it, whatever that is, okay? Now, what if I pick 1 accessory? Well, I still have this many options for the other things, but now I have to pick an an accessory. How many are there? 6, and I'm picking 1. So basically that's 6, so if you put 6, it would be okay. And then, all these are gonna have this, because this is the basic car. And then you're just putting whatever you're putting else onto it. So now I'm picking 2, so that'd be 62, 63, 64, 65, and so on. Now, since they all, so then you could just do that and then add all those up, that would be the total. But basically, okay, this one was 60, you didn't pick any of those. So if we look, and then all the way down to 66, we could have shortcutted this, done it a little bit more efficiently, because, what is that, 60? So you have 60, 60, plus 60, 61, and so on. So if we factor out the 60, because all these terms I'm adding up are gonna have a 60, I would have 60 plus 61 all the way up to 66. And we made an observation about the combination numbers. If you add up all of the 60 numbers, what does it come out to be? 2 to the 6th. So all that stuff there is gonna add up to 64. So you could just do 60 times 64, since you are including the entire row, all of the possibilities are there. Or you can do each one of these individually and add them up. Okay, who else? Anything else from homework? Bronson?
Number 7 for 9.2.
Find the coefficient of the x to the 10th. Okay, so I know if I did this whole expansion, the coefficients would be 12C12, 12C11, 12C10, all the way down to 12C0. Those would be the coefficients. I know next to this guy, if I were interested in that term, it would be 2x to the 12th and 3 to the 0th, right? And this one would be 2x to the 11th and 3 to the 1st. And this one right here is going to be 2x to the 10th and 3 to the 2nd. And the exponent on that x is 10, and I want the x to the 10th term. So this is the term I'm looking for. So I'm going to have 12C10. What is that? 66. So 66. And then I'm going to have 2 to the 10th and 9. 3 squared. Those are going to be the numbers that are attached to the x to the 10th. So we multiply all that together, and it's going to be a big number, but that will be the number. Okay, David?
Can you do 9 to number 3?
9 to number 3. This is exactly the same kind of problem. This time it's to the 10th power, so my coefficients are 10C10, 10C9, and so on. And next to each of these is going to be a 2x squared and a y. And when I start putting the powers on, this is going to be the first on the 2x squared power, that'll be 10. And then here it'll be 9, and so on and so on. So I want to have an x term that's x to the 6th, which means that 2x squared is going to have to be cubed. That's the one I want. So I us have to figure out, okay, so what's the coefficient going to be? Well, when two x squared is to the 10th, it's 10c10. When it's to the 9th, it's 10c9. So when it's to the 3rd, it's gonna be 10c3. And I have that, and then I'm gonna have, what's the second part of the problem? A y. And that will have to be to the 7th, because it's to the 10th power altogether. So your coefficient's gonna be whatever 10c3 is, times 2 to the 3rd, times 8, and that will give you your coefficient. All right, anything else from the homework? All right, I've got a couple I wanna look at on the review sheet, and then we'll take whatever, you wanna look at there. So on the chapter 9 review sheet, which is quite big, there are a few things we need to mark out. So obviously, anything that says mathematical induction, we're not doing. We also did not cover the formulas in 13, D, E, and F. So you will not have to do anything like 13, D, E, or F. There are formulas, those problems are easy, but we just didn't do it. All right, so the first one I want to look at is number 9. In a random check on an assembly line, the probability of finding a defective item is 0.003. So defective is 0.003. So non-defective, or good, would be what? If defective is 0.003, not defective would be 0.997. Okay, binomial probability, one or the other. Find the probability of a non-defective item occurring 10 times in a row. So in other words, you're gonna pick 10 items, and none of them are going to be defective, right? So it's like true or false, it's like multiple choice. There are 10, you're picking 10 items, and all 10 of them are going to be not defective. So not defective is 997, defective is 0.003, and we want all 10 non-defective and no defective. That's it. So you type that in on your calculator, and that will be the answer to the question. Now, number 10 is exactly the same situation. We're tossing a coin 5 times. What's the probability of getting 2 heads and 3 tails? So like 2 defective and 3 non-defective. Now, the difference is, okay, you gotta pick one or the other. It doesn't make a bit of difference. So if you go with heads, we're gonna toss it 5 times, and we want 2 of them to be heads. Now remember, 5C2 is exactly the same as 5C3. So it doesn't matter, I'm doing it in terms of heads. So I'm saying I'm tossing 5 times and 2 of them are going to be heads. Well, the probability of heads is 1/2, and I want 2 of those. And the probability of tails is 1/2, and I want 3 of those. So that all multiplied together would be the answer to that one. Those 2 problems are exactly the same. Binomial probability. All right, number 14, number 14. Here we go. How are you gonna set up number 14? It's not a probability, so please don't make it a fraction. Bronson?
45C3.
Perfect. That's all there is to it. We're not overthinking it. There's 45 people and you're picking 3. We don't care what order they get picked in because they're just a committee. They're not a president, a vice president, and a treasurer. That would be 45P3. 18, how many ways can all these books be arranged in a row? How many ways can they be arranged in a row? Well, how many books are there? 13. So 13 things can be arranged 13 factorial ways in a row. But what? There's another little thing about this problem, Sam.
4 tables are identical.
So we have to divide by 4 factorial. That is exactly the same as taking the letters of a word. If they were repeated, if the word had 4 F's in it, you would divide by 4 factorial. Divide by the repeat. What about on a circular shelf? Same book, same everything, but I'm putting them on the circular shelf. That would be 12 factorial divided by 4 factorial. The repeats haven't changed. They're still there. But when you arrange things in a circle, no beginning and no end, it's 1 less factorial. In a row, with the books of each kind together. So in other words, keep all the geometry books together and all the trig books together and all the calculus books together. So you start with 3 factorial because don't you have 3 kinds of books you're arranging? 3 bundles? But then, within those 3, there's arrangements, right? The geometry books could be arranged 3 factorial ways. The trig books could be arranged 4 factorial ways. And the calculus books could be arranged 6 factorial ways. But these guys are still repeats, right? So you don't even have to put that in there if you don't want to, because it's going to cancel with that. But that would be the official setup of it. Okay? Number 21, find the sum of this. So you'll have a thing with the formulas on it. You don't need to memorize the formulas, but you need to know which one to use. So look at your list of formulas, wherever you have that written down. Which one am I going to use if I'm finding the sum of this guy right here? S sub n, S sub n equals n over 2, first plus last. That's exactly right. That's the formula you're going to use. So we know the first term is -5, and we know the last term is 55. What do we not know? How many there are. So we have a choice. We can start filling in and counting. That's certainly an option. Would be a bad option if this were 5,000 or something. So maybe we should rely on our other formula that says the last term equals the first term plus the common difference times n minus 1. We can solve this equation. Looks like n is 31. Looks like there'd be 31 terms. So whatever that is will be the sum. All right, number 22. Evaluate by hand. Okay, we gotta remember what's our formula for permutations. Bronson?
5 factorial over 5 minus 2 factorial.
Perfect. So that would be 5 times 4 or 20 if we're evaluating it by hand. How about this? We did one of these earlier. This one got numbers in it though. So what would this one look like? 11 factorial over 7 factorial and so 11, about 10, 9 and 8. Everything after that's gonna cancel with this, right? And then on the bottom, we've got 4, 3, 2, 1. So what's gonna cancel there? We get rid of an 8. Is that 330? I think. I did my arithmetic right. You have the calculator on the whole test, so it doesn't matter. You can just type it in. So how can I give this kind of question on the calculator? Put letters in it, right? Because your calculator won't do the letters, so what do you have to do? Well, you gotta know the formula. So what's the formula for this? This is a combination, so it's gonna be n plus 1 factorial over n plus 1 minus 3 factorial and 3 factorial. So let's clean up that. So that's just gonna be n minus 2. Now, eventually we're gonna have cancellation, right? So what are we gonna have before the cancellation starts? Well, we got our n plus 1, and then we'll have n, and then we'll have n minus 1, and then after that, it's all gonna cancel?
Yep.
But we still have on the bottom 3 factorial, which is 6. And that's good enough. You don't need to FOIL all that out. Good enough, just right there. All right, 26. Each NBA team has 12 players. Coach chooses 5 starters without regard to position. How many of our sets of 10 can start when 2 given teams play a game? All right, what's your thought on that? David?
It'll be 24 C10.
I was hoping you would say that because I want you to think about what that means for a minute. Let's suppose, let's give a specific term. So let's say we got the Cathedral 12 and we got the Chpt 12. And Cathedral's gonna play Chpt. Do we put all 24 in the same pool and pick the 10 out of there that are gonna play? No, because we might have Cathedral kids playing against Cathedral kids, right? So we don't wanna put this together. We wanna do what?
12 C5 plus 12
Mm-hmm.
times.
So 12 C5 times 12 C5. Why is it a times? Because you're picking 5 from this team and you're picking 5 from this team. Does that make sense?
Yeah.
Yeah. So this is the way you want to do that problem. Does that make sense to everybody? We don't want to throw everybody into the same pot. Okay, 29. Okay? So what are you thinking about a strategy for this problem? Sam? Definitely Venn diagram. Definitely Venn diagram. So we've got people who like country and jazz and opera. And there's 40 of them. And 6 like only country, 10 like only jazz, and 1 likes only opera. 3 liked all 3. There are 20 who like country, 22 who like jazz, and 16 who like opera. Then we'll reach in and grab 1. What's the probability he doesn't like anything? Okay. Well, we got some empty spaces, don't we? We don't know how many people are in those empty spaces, so, there are other ways to do it, but I think it's just so straightforward to say, okay, let's figure out what those spaces are, we'll assign them variable names, I called them X, Y, and Z. And I know that all four numbers in this ball right here have to add up to 20. So 6 plus Y plus 3 plus X has to add up to 20. So X plus Y has to add up to 11. Similarly, Y plus 10 plus 3 plus Z has to add up to 22. So Y plus Z has to add up to 9. Keep an eye on my arithmetic. And X plus 3 plus Z plus 1 has to add up to 16. So X plus Z has to add up to 12. So what have I got? What am I left with here? A system of 3 equations and 3 unknowns. You could put all this into a matrix if you wanted to. You could, any way you want to solve it, you can solve it. These equations, when you do this, always come out real easy to eliminate. So I'm going to go ahead and take this one. Doesn't matter, I'm just randomly picking here to eliminate X. And when I eliminate, I get Z minus Y equal to 1. But I know that Z plus Y equals 9. So 2Z has to be 10 and Z is 5. And once I know Z is 5, then I know Y has to be 4. And X has to be 7. But again, that's 3 equations, 3 unknowns. You can do a Gaussian elimination or Gauss-Jordan reduction on that if you want to. All right, so what's the deal now? Well, let's see. I'm going to add all these things up. So I know the C ball is 20. So there's 36. So there's 36 people in the circles, which means what about out here? There's 4. So the question was, what's the probability of picking a kid who doesn't like anything? Well, it'd be 4 out of 40, or 1/10. Okay? 30. What's the probability of choosing all clubs in a 5-card hand? Well, first of all, if it's a 5-card hand, the denominator is going to be 52C5 for every single one of these problems. So what's the numerator? All clubs.
52C13.
How many cards am I picking? 5. What am I picking them from? 13C5, yeah. You think about what you were saying. 52C13 means you're picking 13 cards. That's not what's happening, is it? No. 52C13 would be the number of 13 card hands in the deck. All right, exactly 1 ace. A 5-card hand, exactly 1 ace. The denominator isn't changing. That's the denominator. 5-card hand. That's the denominator. What's the numerator, David?
4C1.
Yep, there's your ace. Wait, there's more. Because how many cards am I supposed to have in my hand? 5. How many do I have right now? 1. Where are the other 4 cards coming from? They're coming from the cards that aren't aces? Well, how many cards in the deck are not aces? 48. And you gotta get 4 of those. Does that make sense to everybody? Those 4 cards aren't mentioned specifically. It says 1 ace. But remember, it's a 5-card hand. So you have to have 4 other cards that are not aces. At least 1 ace. At least 1 ace. Well, what does that mean? You could get 1 or 2 or 3 or 4. So could we, this is one right here. Could we set up 2 aces? 2 aces would look like 4C2, 48C3. Would you agree with that? And 3 aces would be 4C3, 48C2. And 4 aces, and all of these are over 52C5. And 4 aces would be 4C4 times 48C1. And what would I do with all those individual things? What would I do with all of them, Adam? Because it's 1 or 2 or 3 or 4. And I could add all those up and divide by 52C5, and that would be it. That's a lot of work. Think about it. That's the probability of getting at least 1 ace. What if I did this? What's this? Probability of no aces. You can add that on if you want. What if I just took 1 or 100, 1 minus the probability of no aces? Would that leave me with the probability of at least 1 ace? So yeah, that would be a faster way to do the problem. But it doesn't matter, then it gets the same answer no matter what. All right, no face cards. What's the probability of getting no face cards?
45.
Yeah. Right there. Because there are 12 face cards, take them out. That leaves you with 40 other cards to pick from. .36, a ball is dropped from a height of 50 inches. Each time it hits the ground, it rebounds 2/3 of the distance it fell. How high does it go after it hits the 6th time? How far does it travel before coming to rest? Okay, the bouncing ball problem. All right, so here it is. It's dropped from 50, bounces up 50 times 2/3. And each time I just keep multiplying by another 2/3. This is geometric, right? So the first question says, how high does it go after it hits the 6th time? Well, how high does it go after it hits the 1st time? 50 times 2/3. How high will it go after it hits the 2nd time? 50 times 2/3 times another 2/3. So how high is it going to go after it hits the 6th time? Madeline?
50 times 2/3 to the 6.
Yep. So whatever that is, inches, that's how high it's going to go after it hits the ground the 6th time. Now, second question says, how far does it travel before coming to rest? So we talked about this yesterday. Let's look at the downs. What formula am I going to use? It's geometric. summing up all the downs. We're gonna find the sum of all the downs. What formula am I gonna use? David?
The infinite one.
Yep.
Is A1 over 1 minus R.
Exactly, so it's the first term over one minus the ratio, and isn't our ratio 2/3? So that's 50 over 1/3, or 150. So all of the downs are 150. So what are the ups?
The same as the downs, except minus 50.
So it'd be 100, right? The ups are exactly the same, except for this guy, because the ball was dropped. So what's the total distance it travels? 250 inches, right. Under what circumstances would the downs and the ups be exactly the same? Alan?
If you threw it up
If I
first,
threw it up, yep, because if you throw it up, then they match up perfectly. They're exactly the same. All right, 38, 5 couples go to a movie. How many ways can the 10 people be seated in a circle? You're getting the, I can't believe you don't know that answer stare.
what is it?
9 factorial. How many ways can 10 people be seated in a circle? 9 factorial. Period. That's it. Now, we're going to put them in a row, but they have to sit with their date. So in other words, if Bronson and I go to the movie, we have to sit together. Well, what? Here's a couple, there's a couple, there's a couple, there's a couple, there. So we've got 5 couples, right? So what's our thought? Ava?
It would be 5 factorial times 2 factorial.
Okay, now, let's talk about that for a second. Tell me why you said 5 factorial.
Because they have to sit with their dates, so there's 5 options.
Exactly.
And then,
So there's 5 couples, right? So we're going in, we got 5 things we're arranging. So I agree with you 100%. Tell me where the 2 factorial came from.
because within the couple, you can sit 2 different ways.
Exactly. So with Bronson and I, that's 2 factorial. But what about with you and Maggie? That's another 2 factorial, and another one, and another one, and another one, because each couple can be rearranged. Right? Okay. All right, so now I'm still picking problems to do. There are lots of problems on this sheet. All right, let's look at number 3. Find the 4th term of this expansion. I think I already did something like this. That was a homework question, but let's do this anyway. The 4th term of this expansion. Remember that an expansion, each term has 3 parts. Each term has a coefficient, a power of this, and a power of this. All right, so what's the coefficient? Well, in the first term, the coefficient would be 7C7, and then 7C6, 7C5, 7C4, and I want the 4th term, so it's gotta be 7C4. Now, please understand that that 4 is not because it's the 4th term. That 4 just happens to be, when I count down, the 4th term. The second term is not 7C2, it's 7C6. All right, so just count down. All right, so there's my coefficient. Now, I'm gonna have a 4A and a negative 3B. This is a multiply, not a subtraction. This is a multiplication. 4A will be to the 4th power, 7, 6, 5, 4. That means 3B is to the 3rd power. So when I multiply this, I am going to have to multiply, I mean the whole fourth term, so I'm gonna have to multiply 7C4 times 4 to the fourth times -27. So I have -241,920 a to the fourth b cubed. All of that gets multiplied together to get your answer. Right, number 8. All right, what do you think? Strategy. What's our strategy? Drew? I do a tree, yeah. I would do a tree. So when I do my tree, something happens and then something else happens. And the question is, find the probability that, well, it's all about Mother Earth winning. So we're gonna have wet or not wet. And we're gonna have win and not win. All right, if the track is wet, she has a 70% chance of winning. So this would be 0.30. If the track is dry, not wet, she has a 40% chance, so 60% chance of losing. Weather forecasts predict an 80% chance it'll be wet. All right, so now we got several questions. Everybody okay with the chart here? All right, so here we go. The track is wet and she wins. So that would be 0.80 times 0.70. Wet and win. The track is not wet and she wins. That would be 0.20 times 0.40. Keep an eye on my arithmetic there. So what's the total probability she wins? 0.64. Just add those together because she can win when it's wet, or she can win when it's dry. So we're going to add those two together. So that's the total probability that she wins. Now, the next one, the last one says, what's the probability that when the track was wet, given she won? Well, we have a formula for that, right? No, put it in your bag. You people can't handle it. Put it in your bag. I don't know what it means, but it's another infraction. Okay, so anybody remember our formula for this? I'm not giving you this. This one you gotta know how to calculate conditional probability. What is it?
The probability that both happen over the probability that the given happens.
So it's the probability of both, so win and wet, this was wet, win and wet over the probability of the given, which is the win. All right, so what's win and wet? Wet and win is this one, so that's 0.56. And the total probability of a win was 0.64. So that simplifies to 7/8. Oh yeah, I guess I could have done that myself, but oh well, 7/8.
we gonna mark it wrong on the test if we write it in percents?
Nope. I will if you round it off. So use fractions if you have to round it off, but yeah. And if it doesn't change, sometimes in the card problems especially, it doesn't change into fractions because the decimal's so accurate, and you have to just write down whatever you can. Okay, but like on this one, if you put 88%, I would mark it wrong. If you put 87.5%, that's perfectly fine because that's what it is. All right, so that was 8. All right, 12. Did we do 12? No, I think so. Okay, so 12 says, write in summation notation. So, what does that mean? Summation notation means sigma. You don't have to start with 1. There will be times, maybe, weird problems. You don't want to start with 1, but it's easiest just to start with 1. What goes here? What goes here would be your explicit term. Because don't you want to plug 1 into it and get -8? And plug 2 into it and get -3 and so on? So you're going to put your explicit term right here. Well, what kind of sequence is that? Arithmetic. So the explicit term is going to be the first term, which is -8, plus the common difference, which is 5 times n minus 1. So that's going to be 5n minus 13. So look, if you plug 1 in, do you get -8? If you plug 2 in, do you get -3? Yeah, that's what you need. You need your explicit term. What's missing? Awesome?
The number on the top that
The
tells you.
stopping point, right? Because this sequence stops. So you need to figure out the number that you plug into here that would give you 92. That's easy. What gives you 92? So it looks like 21. Did I do my math right?
Yeah.
And there's your sigma. Now, there's another one there. What is different about the second one? It's geometric. All right, so I'm going to start the same way, but now I need my explicit term for a geometric sequence. So that's first term times ratio. What's my ratio? -2 to the n minus first. That doesn't simplify. Please don't try to simplify that. It does not do anything. So 4, -2 to the n minus first. Notice if you plug in 1, you get 4. So this is good. But again, we have to stop, right? So I have to figure out what I put in for n that would give me -2048. Right? This is a little harder to solve. What do you think we should do first? Divide by 4, absolutely. -512. Sam?
And then, because we know n has to be a whole number, we know that 512 is -2 to a power.
Yep. So 2, I think it's 2 to the 9th. So we know -2 to the n minus first equals -2 to the 9th. So therefore, n minus 1 equals 9, so the stopping point is 10. Now, the opposite kind of that is evaluating a sigma. So in number 13, we have 13A, we have to evaluate. So this is it. Notice there's an infinity up here. I usually just leave it blank, but that means it's infinite. So that's a different formula than we would use for that problem. It is the bouncing ball formula. So first term, what do we get if we plug in 1? Plug in 1, that gives you the first term, 3/2. And what's my ratio? You can tell from the problem. What do we keep multiplying by? 3/4. Is that 6? So the answer to the problem is 6. Easy. Now be careful on B. You can type in a formula. You can get an answer, but it will not be right. It won't be right. You'll get a number. You'll get a number. But what's going on here that's not right, Ben? Exactly. The ratio is bigger than 1, therefore this one, B is not summable. B is not summable. It doesn't work. All right, 31. Find the first 5 terms of this. And they already give you the first 2. All right, here we go. What's the first term? Oh, it's 4. Second term's 1. Okay, got it. Third term. Well, to get the third term, I'm going to have to let n be 1. So if I let n be 1, it says the third term is 2 times the second term plus the first term. Would you agree with that? Robert, what's on your iPad? Huh?
Review answers.
Okay, well, we're going through the answers, so why don't you put that down? Thank you. All right, so 2 times the second term plus the first term is 6. So now how am I going to find the fourth term?
2.
Well, I can let n be 2, or I can observe the pattern. Isn't it going to be 2 times the third term plus the second term? Yeah, 3 and 2, so 2 times the third term plus the second term. So it'll be 12 plus 1, 13. And finally, the fifth term will be 2 times the fourth term plus the third term, which is 32. 26 plus 6. All right, 32. Find the limit. Here we go. We gotta be able to snap through this. Find the limit. A. Number 32, the limit of A. 1. N over N. B. 0. C. No limit. Divergent. Right. D. 0. If the if the number you're raising to the power is less than 1, the terms are getting smaller. That's why you can sum them. That's why you can find the sum. How about E? 0. I don't care what else is in the problem. It's 0. F? 3/2. G? Divergent, no limit. 6/5 is too big. H? 0. What's n to the negative first? 1 over n. 1 over n. It's going to get smaller and smaller. I,
Just divergent.
what's happening in those, it's not arithmetic or geometric, but there's a definite pattern. What's happening? It looks like the top number is always two bigger than the bottom number. Oh shoot, I forgot, yeah. So, we have a little bit shortened periods today. So, if the top number is two more than the bottom number, what would the limit of that be? One. I heard some of you say zero. It's not ever gonna get close to zero. Well, I mean, it's gonna get close to zero, but that isn't its limit. Because won't the top always be bigger than the bottom? So won't it always be a little bit bigger than one? Yeah. All right, you have a test next time I see you. Oh, you're welcome, over chapter 9.